Thank you very much. So I'll present myself real quickly. I'm Matteo Andreottola. I'm a technical consultant for Rothoblaas. Today we're going to see innovative connectors for CLT and mass timber structures. So that's a list of the topics that I'm going to discuss today, but we're going to talk about them in details right now. First of all, I would like to start with the two standard approaches when we talk about timber design. So the standard approach is having a shear wall with hold downs at both ends and shear connectors in the middle. A more innovative approach to do the shear connection of a shear connection, a tensile connection of a shear wall is having a connector which can support both the tension forces and the shear forces. And I'm going to present as well a lot of other connectors, and hopefully at the end of the presentation you will be able to choose the correct connector for each situation in your CLT building. So just for a start, nowadays we are not only building private structures with timber, but we are going towards very big structures, multi-story structures like the one you can see in the right. So this is possible thanks to the innovative materials, like for example CLT. Those are engineered materials, and I strongly believe that to be able to build such structures, it's important to to grow as well in the connections, which are definitely the key of the design in this case scenario. Here in the images, you can see the ground connections of, for example, a 9-story CLT building in Rovereto, very close to the north of Italy, where Rothoblaas is placed. So what about these modern angle brackets? As I said before, in the innovative approach, you can have the same connector which can handle at the same time shear forces and tension forces, as you can see in the image. So just by adding this this thicker plate at the base here, you're able to increase the inertia of the plate itself and withstand the tension forces without bending the angle bracket. So as you can see here, the resistance is quite high. Another possibility to have the same connector for shear forces and tension forces is having this other connector here. Instead of this one here, instead of having normal nails, which they take more time on site to install, it has bigger screws, so 8mm diameter screws. And the advantage here is that you take less time to have the same resistance, the same angle bracket with the same resistance. So it's quicker on site. So that's the advantage. And by the way, you can use a drill to install it on site, and that means that you have less noise. It's quicker, and it works better. Another very innovative angle bracket is this one here that you can see in the image. This one here is another very well engineered angle bracket, innovative one, because you minimize the eccentricity that you have on your connection by adding these full threaded screws at the corner of the connector. So basically, by by removing the eccentricity, you make sure that you get to a very high resistance. And in fact, you see here that the resistance, the timber resistance is roughly 100 kilonewton characteristic. So that's definitely a very high resistance. And another advantage is, for instance, that if you have a multi-story construction and you want to change the thickness of your CLT panels, you can do it with this connector here without needing a through bar, which needs to be aligned, of course. And another advantage that you can see in the right image is that, for example, if you want to keep visible your CLT panel, you can do it without any issue, because the connector stays under the finished floor level of your floor. Of course, all of these connectors were tested, and it's important as well to talk about the ductility of the connector. In fact, as you know, timber is a very resistant material, but is not a ductile material, and therefore we need to place into the connections all the ductility of our system. And this is why this kind of connections work very well, because you have a lot of a series of small diameter connectors which can really easy bend and therefore have the right ductility. Another very important connector that I wanted to discuss with you is ALUSTART. So a key thing for our structures, timber structures, is to have the right durability. In order to have the right durability, as you can see in the images here, you need to rise your building from the ground in order to avoid the capillarity and the water drainage coming from all sides. How do we do this? So we can do it with a very simple concrete wall. That's definitely possible, but the tolerance that you have in the CLT panels is not exactly equal to the tolerance that you have to the concrete on the concrete wall. And that means that sometimes you have issues on site. So how do we solve the issue? This is exactly the product that solves both of the issues. So it's at the same time, it enhances the durability because it separates the structure from the foundation. And second of all, it is also a structural connection. So it can withstand both shear tension forces. It can use as a hold down, this one here, and as well, of course, tension in compression force, because it stays under the connectors. You can place a full nailing or a partial nailing depending on how big your forces are. And the other good thing is that you get a very precise layout, and you can actually, with jig starts, which are basically dimes, to have it perfectly flat, you can control the inclination as well of the support. As you can see here, you can make it precise in both directions. To finish it up, you just pour some incompressible concrete below it, and your connection is done. It's super quick and super efficient on site, and it enhances the durability a lot. You can decide to use both nails or other fasteners, like for example, this 5mm screws. And to connect concrete, you can use screwable mechanic anchors or expansion anchors or chemical anchors. Here as well, it depends really on which one you choose, the resistance that you get, basically. This is again a picture of the different possibilities that you can get, and here are the resistances that you get. The biggest advantage here is that you don't need a lot of angle brackets, and this is a very good thing, because you really save up a lot of time with not needing to place all these angle brackets. You can place extra hold downs or not, depending if the tension resistance of the connector is enough or not. These are all the three resistances they have to calculate. They're actually pre-calculated in Rothoblaas technical sheet. So the calculation of this is very easy. And you can see here the vertical resistance of the compression resistance of the extruded aluminum profile. It's very high, and that means that you can use this one with as well for multi-stories constructions, like we were saying before. Main advantages are definitely the time, because you're super fast and very precise at the same time. You can see here some of the pictures on site, some pictures of the dime and the construction site, which is very clean. Another very interesting and innovative connector is as well the slot connector. And let's see what's the use of it is exactly. So if you have a continuous shear panel, it might be very long and might work very well, but in order to transport it to the site, to the construction site, you need to cut it in pieces. If you need to cut it in pieces in order to recreate the continuity of the shear panel itself, you need a lot of screws and a lot of time to place those little panels together. And you lose a lot of the stiffness of your shear panel. So What's the way to solve this? We can use, for example, this slot connector, and it's a very simple extruded aluminum plate, basically, 3D plate. And just by placing it here and by placing 2 screws to make sure that it's not going anywhere, you finished off your connection. You can see here the resistances that you get. These are calculated depending on how many layers you have. Again, here the calculation is very easy. It's all already included in the technical sheet, and that's again what you can reach with this kind of profiles. So instead of having a behavior of the wall like the one on the left, you have a very stiff behavior like the one on the right. These are some pictures that you find on some drawings that you find on the website. And here is a test for resistance and as well deflection that we've done with exactly the same panel connected with slots and connected with timber. So as I was saying before, the time really does the difference here, and as well the resistance of this connector is very good. Here again, the tables that you have on the technical sheets that gives you the resistance depending on how many layers and depending on the thickness of your CLT panel, and you can use it for floor panels and for wall panels as well. They work on both. Another very innovative, and this is definitely really remarkable as an innovation, is the spider connector. What is it exactly, and what's the concept of it? So you've seen definitely some of the structures like the one that I'm showing you right now in concrete without any secondary structure. Basically, what's the problem here? What's the issue? It's the punchy shear in the concrete. So in the concrete, the designer resolved this with some reinforcement to avoid punch and shear. We can actually do the same with timber, and avoiding having secondary structure, remove it completely. That of course makes you gain a lot of room in your building, in your structure, and you have a lot of place for other installations that has to pass through just below the ceiling. And of course you have this nice finish, very simple, and you can keep visible, for example, the CLT slab, and you have this very nice finish. How does it work exactly? It has these arms, these steel arms that go in all directions, and attached to these arms, you place some inclined screws, and the inclined screws basically they take the load from the floor, and they bring it up again, and they bring it down through this steel column that you have in the middle. So all the total load is on the down column here. And what's the use? There's another use for these inclined screws. When you have punch and shear in a timber connection, it basically means that you have rolling shear into the timber. So basically, these inclined screws are as well a reinforcement for the rolling shear. Again, all the resistances are already tabled into the technical sheet, so it's very easy to calculate those, and you can have without needing a lot of time a very nice solution. First of all, to remove completely your secondary structure, and second of all as well, we didn't say it before, but it's of course another advantage. You resolve the issue of the compression perpendicular to the grain in the CLT slab, because that's another issue that you have. Another advantage is definitely that you have a continuous slab. That means that the graphic of the bending moment is the one that I'm showing you right now on the right. And with this graphic of the bending moment, since it's continuous, you can actually reduce the thickness of the CLT slab. That's how it has to be assembled and installed on site. And make sure to do it correctly. it's a steel to timber connection, so it has to be installed in the right way. It's a very easy installation, and this is another interesting feature, because if you want to achieve a continuous slab, of course, you cannot bring it to the site just as a single piece. So you need to cut it in pieces, and you can recreate the continuity by adding these plates with the Xepox epoxy resin. Another way is to have a continuous slab that acts really as a secondary beam, and you place all the other panels 90 degrees to create the structure, basically. It saves a lot of money on the material because you don't have the secondary structure, and you have a lot of extra room, as we said before. You have a lot of room for installation and the nice architectural finish. The pillar connection is very similar, and the good thing about this is that you resolve the issue of the compression perpendicular to the fiber, and it's a very you can pretty much do the same thing, have this continuous slab over, and and by the way, this was done in some buildings already, and basically it works differently because you don't have the arms all around it, and so basically all the forces are brought down by simple support. So that's the main difference. These are the how it is. It needs to be installed on site, and as we said before, it's a simple bearing of the floor slab onto the column, and you have this inside column that resolves the issue of compression perpendicular to the grain. It has resistance as well for the uplift, and you can reinforce as well with screws, as you can see here. You have exactly the same methods to create the continuous slab, as you can see here, and you can have good spans, see up to 3.5 meter of span in this direction and 7 meters on the other direction. Another very important and innovative connector is the sharp metal. So basically with this one, you can create, as you can see in the images, floors that are made of 2 different structural elements, and you can make them work together as a single piece. And basically how this one works is you have first of all, you have 2 sets of different with different geometry, and you place them together with simple partially threaded screws that really push them together in a way, and you have a very stiff connection with a lot of resistance. So as you can see here, you can achieve the full penetration just with the screws, and the resistance are really maximized. One of the last connectors that I would like to present you is the Xram. I'm almost close to the end of my presentation. This is again another very innovative connector. It is innovative in the sense that you have all the forces concentrated in the corners of your panels. You have the X1, which is this part of the connector, which is one of the main elements. Very high resistance thanks to these inclined screws, and of course it's all calculated with this domain of resistances. If the force is inside of the domain, the connection is verified. All the vertical forces are brought down by simple support of the panels, and the horizontal forces are behaving in this way inside of the panel. So like basically it works very well because it's very stiff, the panel. It's the shear wall is very stiff, and you can use the same hooks for the lifting and for the movement of the panels as well. So with just one thing, you're able to apply the connector maybe in the factory. You use it to move it around, you move it to put it in place, and you have a very high resistance of the connector. So that's it with my presentation.